Okay, here we go. Pay him? You're already paying me. Why pay him when you're already paying me? Okay, here we go. So you have three functions, f of x, g of x, and h of x, okay? Your test, by the way, looks eerily like this worksheet, just in a different order, but really similar ideas. So if there's anything from this that you don't know how to do as we do it, you should stop me and tell me that, and we'll try to make it understandable, okay? Okay, here we go. So first one says take f of x and add g of x to it. So you're just taking those two functions, f of x and g of x, and adding them together. 5x plus 3 plus x squared plus 2, okay? When we do that, what's your first term in your final answer? What's going to come first? We always want standard form, x squared. We're going to take the x squared, and that's going to go first, okay? So we use that. Then what?
5x.
Plus 5x. Going to go right there. Then what? Plus 5. You have a positive 3 and a positive 2, and we are adding them together, plus 5. So that is f of x plus g of x, okay? So that's addition. Number 2 is subtraction. And be careful with subtraction because you're subtracting an entire function, which means you're subtracting all parts of it, okay? So h is 2 of x. 2 of x. h of x is 2x is what I should have said, minus the f of x. So minus, put it in parentheses, 5x plus 3. Okay? That means when we actually subtract, we need to subtract both parts. Okay? What's that going to look like?
A math problem.
Uh-huh. 2x minus 5x? Negative 3x. And then is it plus or minus? Minus 3. That is your final answer. Okay? All right, division. G of x divided by h of x. So g of x is x squared plus 2 divided by 2x. What can be simplified about that? Nothing. That's as low as we can go, right? If this is an expression on top, x squared plus 2, you have to be able to divide by something in all parts of that. And we can't. There's nothing that x squared and 2 can be divided by, okay? So we're going to leave it like that. But we also need to say what?
Oh, it can't be negative 2x?
Not negative 2x. 0, right? X can't equal 0. If I plug a 0 in right here, then my whole denominator will equal 0, and it can't. All you do for those is you set the denominator equal to 0, and you solve. If I divide by 2, x is 0. So x cannot equal 0, and this is our division problem. Okay? What? Okay. Number 4, what are you doing there? What's your operation? Multiplication, yeah. So we're going to take h of x, which is 2x, times f of x, which is 5x plus 3, right? So we're just multiplying the two functions. What do you have to do?
Foil.
It's not a FOIL, but it's same idea. Distribute, yeah. So 2x times both things, right? 10x squared plus 6x. Some of you on the quiz tried to simplify that by dividing by 2 and calling it 5x squared plus 3 or 5x plus 3, dividing by 2 and taking the x away. You can't do that, okay? This is not set equal to something right now. If you can do something to both sides of an equation, then sure. But this is just an expression. You can't simplify it, okay? Okay, questions on those? All right, then 5 through 10, you're plugging values in for your f of g of whatever functions, okay? So number 5, we're saying what is f of 5? What do you do for that? plug it in for x in which function? In the f of x function. So you're going to come up here to f of x, and you're going to say 5 times 5 plus 3, or 28. Okay? So just keep in mind, when it's something like this, when this is what it looks like, right? All of these problems, well, minus this one because that one's a variable. If there's a number there, your answer should be a number in the end, right? If you're plugging a number into a function, you should get a number answer out of it, all right? Okay, then get all this out of here. Look at number 6. What do you do with that? What do you do first? G of negative 3. So you're going to say G of negative 3 is negative 3, parentheses matter here, right? Negative 3 squared plus 2. What does that equal? 11. Yeah, negative 3 squared is 9. 9 plus 2 is 11. Okay, so G of negative 3 is 11. What do you do next? Yes.
Plug it in for f.
Plug it into the f of x function. So now we're doing f of 11, right? So that 11 is going to go right here. 5 times 11 plus 3. So 55 plus 3 is 58. Please put circles or boxes or highlight your answers, by the way. It's really helpful. Okay, number 7. H of f of negative 10. What do you do first? F of negative 10. So you're going to take this negative 10 and you're going to plug it in to f, right? So 5 times negative 10 plus 3 is a negative 47. Now what?
H of negative 47.
Yeah, plug that negative 47 into our h of x function, which is the 2x, right? So negative 47 is going to go here. 2 times negative 47 is a negative 94. So far, so good? Okay. Number 8, G of f of 0. What do you do first? This one looks a little different, right? They did the dot now, but really all it's saying is this, G of f of 0, right? It's the same thing in a different format for the notation. So where do you start?
F of 0.
F of 0. Yeah, so we're going to plug, you know what, I'm going to take a quick picture of these and drop it down here so we can see it a little better. Okay, so if it's f of 0, the 0 is going to go into our f of x function. So 5 times 0 plus 3 is 3. And then we plug that 3 into what? G. Yeah, so that's going to go here in our x for our g of x function. So g of 3 is 3 squared plus 2, or 9 plus 2, which is 11. Okay, so plug it into f first, and then whatever you get from that, plug that into g. Okay. Look at number 9. 2 h's. H of negative 2. What do you do?
H of negative 2.
So we're going to start with h of negative 2. And that's going to be 2 times negative 2. So a negative 4. And then what? H of negative 4. Now plug the negative 4 into your h. So 2 times negative 4 is negative 8. And that will be your answer. Okay, now number 10. This seems to be the one that throws people the most. I actually think it's easier than the other ones because you only have to solve one thing. But I think people just let it trip them up a little bit. So here's how I want you to see this, okay? It's f of h of x. So you're gonna start inside with h of x. That part of it is already done for you. They're saying plug x into the h of x function. Well, my h of x function is this, and they already plugged x in. It's 2 times x, right? So there's nothing you have to do for that first part of it, but then you're gonna take that 2x, and you're gonna plug that into the f function. So I'm gonna take 2x, I'm gonna bring it over here, and I'm gonna replace the x in this function with that 2x then. So it's gonna be 5 times 2x plus 3. What is that? 10x plus 3 is as much as you can do with that. And that's your answer. Okay, so don't let the variable freak you out. Essentially what you do is you take the inside function, and you take that whole function and drop it in place of x in the other function. Okay? Okay. Any questions so far? Okay. 11 and 12, you're taking your f of x function and your g of x function, and you are defining the domain and the range of each of those functions. So first of all, look at f of x. Okay, that's this 5x plus 3 is our f of x function. What type of graph is that? What does that look like? It's a line, okay? Now, the beauty of a line is it keeps going in every direction that it's pointing. So if a line is pointing like this, it's gonna keep going that way and keep going that way forever. Which means, what is your domain? All real numbers. It just keeps going, okay? What's your range?
And also,
All real numbers, because you can have as high as you can go on the graph and as low as you can go. So your y value can be infinity or negative infinity, right? So all real numbers, if it's a line, always, okay? Then look at 12. G of x is x squared plus 2, right? That's your function, x squared plus 2. What does that graph look like? It's a parabola. Do you know what has happened to that parabola? It went up 2. Okay, so I'm just gonna give you a quick freehand sketch of this. 1, 2. The parabola is gonna look something like this, okay? Think about your x values for that graph. Is there somewhere going this way that you could not put one of those x values in?
that's all.
That is all real numbers, okay? Your x values, the left and the right, you can go as far as you want. So all real numbers. Are there y values that can't happen from that graph? Yeah, where are they?
Anything less than 2.
Anything below this line, right? It can have all these y values going up as high as you want into infinity, but you can't have anything down here. So that's saying the range has to be greater than or equal to 2. Okay? Questions? Okay, find the inverse. How do you find an inverse? Swap what? X and Y, yeah, the two variables we're working with. So if they're saying find the inverse of f of x and g of x, here's the notation for it, the inverse of x, okay? Look at your f of x function. Now, it started as f of x equals 5x plus 3. Don't let f of x throw you off. What's another way of saying f of x? Y, okay? So just call that your y for now. Y equals 5x plus 3. If you're gonna swap your variables, it's gonna be x equals 5y plus 3. But then from there, you have to solve for your y. You gotta get y by itself, okay? The way we do that is we take away 3. So x minus 3 equals 5y, and then what? We want to get y by itself though. Divide by 5. Yep, divide by 5, divide by 5. So this is your function. X minus 3 over 5 is the inverse of f of x. Okay? Okay, now look at g of x. G of x is this guy up here. So basically, the function is y equals x squared plus 2. What do? Swap them. So we're going to say x equals y squared plus 2, and we want to solve for y. We want to isolate the y. So the first thing you're going to do is take away 2. So x minus 2 equals y squared. What's your next step? Square root. And when you square root both sides of an equation, what happens? Plus or minus. Okay, so we get y equals plus or minus the square root of x minus 2. That's your inverse, okay? If you want to write it in inverse notation, it's this. The inverse, g inverse of x is plus or minus the square root of x minus 2. But honestly, I'm fine with that. How are we doing? Okay. Number 15 on the quiz, a lot of people tried to make very challenging. It was not supposed to be challenging at all, okay? Let me show you how to make this not a challenging problem. Do you know how to graph this?
Yes.
How do you do that?
Like, well, you move down 6 places, and
Mm-hmm.
then you go, the slope is up 2 over 1.
Yeah, so slope-intercept form, you plot your y-intercept first. 1, 2, 3, 4, 5, 6. Okay? Now the slope is up 2 over 1. Okay? And if you want to be done at that point, you can. I like to keep going just because I like to get a nice straight line. So I'm going to do those 4 points, but you don't have to. Technically, you only need 2. Okay, so that's part A. Part B says graph the inverse. You do not need to calculate what the inverse looks like, what the equation is from that. You can, but it's going to be a pain in the butt to try to graph that. Instead, here's what I would do. My original function, okay? I gave 4 points. You really only need 2. So pick 2 points from this line that I drew. So I'm going to pick the point 3, 0. And I'm going to pick the point 0, negative 6. Okay, those are points on my original function. The inverse is just going to flip those x's and y's.
I just flip the points over that y equals x.
That's great too. Yep, flip it over the line y equals x. So for this one, it would be 0, 3 and negative 6, 0. Well, 0, 3 is here. Negative 6, 0 is here. So that would be this line. Okay, that's all you got to do. No need to rearrange the original equation. Flip your x's and your y's and you're good to go. Okay, questions? Page 2. Moving right along. Do you need to stretch? Move around a little bit? You okay?
Are we going to get to the whole worksheet?
I don't know. We'll see. Hopefully as much as possible. Yeah. Yeah. Leave your phone here though. Okay, 16. Simplify no negative exponents, okay? What? Okay. So number 16 here. What's another way to write 3 to the 1/3 power?
3 cubed to the first power.
Cube root of 3 to the first power.
Yes.
Yes. So that would be the cube root of 3. This would be the cube root of 9. What do you do with that? Can you multiply those? You can, right? Because they're both cube roots. So it's going to be the cube root of 27. What is the cube root of 27? 3. You know how you can check that on your calculator? Math 4, right? Is a cube root. Double check it. So you get 3 there. But show me your work on these because I want to see how you got to where you got, not just that you knew how to plug something into a calculator. That's not the point. What? At least show me this, right? Show me what you rearranged it to and then worked it out.
I did that.
Well, write it down. Okay, 17. This one, you're going to break down into the number part of it and the variable part of it. So we're going to take this 2/3 to both of these parts, okay? So it's 27 to the 2/3 power. And then what's x to the 12th to the 2/3? What are you doing with that 12 and the 2/3? You multiply them. When you take a power to a power, you multiply, okay? So this is x. If I multiply this, I get 24/3 or 8. Okay? 27 to the 2/3 power is this. 27 cube rooted. And then square it, right? The root is on bottom. That goes where your index is. The power goes on top. You square it. So the cube root of 27 is 3. 3 squared is 9. So you have 9 times this. Okay? Questions on that? All right, number 18. What do you do with this one? Distribute. Yeah, take that 1/2 power to both of these things. So 64 to the 1/2 power is the square root of 64, right? Anything to the 1/2 power is the square root. X to the -8th to the 1/2, you're going to multiply those. So that's x to the -4th. What does that become? 8 over x to the 4th, right? If it's a negative exponent, move it to the other spot. If it's a numerator, make it a denominator. If it's a denominator, make it a numerator, okay? All right. Excuse me. 19. This one also, you're going to distribute. So take that 24 and multiply both of those things by 24. So you get x, -2/3 of 24. Anyone know?
16.
-16. And then 3/4 times 24 is going to be y to the 18th. Okay, again, you can just plug that into your calculator, 3/4 times 24. It'll do it for you. There's one thing left to do here. What do? Put the x on the bottom. Move your x down. So x to the 16th, y to the 18th. What's on top?
1.
Just a 1. That's going to be your answer. Is this all coming back? Hopefully, for your test tomorrow. By the way, tomorrow morning, 7:45. If you want to come in and go over anything, I'm here. Assuming my children get ready in the morning, that is. And my dog doesn't do something stupid in the morning. Fingers crossed. Okay, so number 20. If we distribute that -15, we end up with x to what power? 3/5 of -15?
45.
-9. So -45 over 5, right? -9. Y to the -1/3 to the -15. So -1/3 times 15 is a positive 15/3 or a positive 5. Okay. And then you still need to simplify that one step further. So y to the 5th will be a numerator. X to the 9th is going to move down because of the negative. And that is your answer. All right. 21. What do? I'd flip first, right? Make that negative go away. So we're going to think of this as 1 over 81 to the positive 3/4 power. And then how do you take 81 to the 3/4 power?
The fourth root of 81 to the third power.
Fourth root of 81, and we're gonna cube it, okay? And at that point, you can totally plug it into your calculator, that's fine. Fourth root of 81 cubed is going to be, this is still over 1 over 27. You remember how to plug a fourth root in on your calculator? 4 math 5, right? 4 math 5 is a fourth root. Okay, 22. I think we're doing pretty good, guys. Might get through this. We're going to distribute all of these. Anyone know 2 to the 4th power off the top of your head? 16. 2 times 2 times 2 times 2. X to the what? 20th. When you're doing a power to a power, you multiply them. If it's x to the 5th times x to the 4th, that's when you add them, okay? So x to the 20th, y to the 12th, and z to the 0, which is 1. So don't put it, okay? Simplest form looks like that. 16x to the 20th, y to the 12th. All right, 23. Let's do some simplifying here. So you have 6 over 9, which will reduce to 2 over 3. And I feel like this is where a lot of mistakes get made, you guys. What do you do with this? You subtract. Be careful when you subtract. Negative 3 minus 2. That's a negative 5. Okay, so you have x to the negative 5th. Then this one, 4 minus a negative 2 is y to the positive 6th. So all you got to do is move this one down. So it's going to be 2y to the 6th over 3x to the 5th, and that's going to be your answer. Good there? Okay. 24, how would you rewrite this in radical form? Is it a square root or a cube root?
Cube root.
It's a cube root, right? The root is on bottom. I think the roots go down. So cube root of x squared, or the cube root of x squared. Okay, you may do either one of those. You don't need to do both. Pick one. Do the one you like better. 25. How do you rewrite this in exponential form? A to what power?
3/5.
The 3/5 power. A to the 3/5 power. All right, 26. What do you do first there?
Move the 5 over.
Yeah, move that 5. Isolate, right? You always want to isolate the radical. So it's going to be the square root of 6x plus 1 equals 5. And then what? Square them both. So square this. We get 6x plus 1 equals 25. And now just basic algebra. 24 equals 6x. Divide by 6. So x is 4. Okay, 27 is a little different, but very similar ideas, right? We want to isolate. This one we've already isolated, or they isolated it for us. What do you do once that power has been isolated? Take everything to what power? 2/3, the reciprocal, right? Take it to the 2/3 and take it to the 2/3. So this one is 1, so you just get 7x minus 3. Anyone know 8 to the 2/3 power off the top of your head? You can plug that into your calculator, by the way. It's 4. 8 to the 2/3 power is the cube root of 8, which is 2, and you square that, which is 4. Okay, then from here, add 3. You get 7x equals 7, and then divide by 7, So x is 1. ¿Está bien? Okay. Last page. And these have been a little while, so let's work through it here. 28. We're going to simplify this. Notice it's a cube root. So we're looking for perfect cubes and not so perfect cubes. Start with the number of 8. What's going to go under the perfect cube side? 8, right? 8 is a perfect cube. Okay, x to the 6th. How much of that goes under the perfect side? All of it. X to the 6th. Y to the 10th. How much of it goes under the perfect side? 9. It has to be divisible by that front number, right? So it's divisible by 3, which means there's one y left over here. Okay, now we cube root it. Cube root of 8 is 2. Cube root of x to the 6th is what? X squared. You're dividing. 6 divided by 3. And then y to the 3rd. Divide. 9 divided by 3. Okay? You're left with, don't forget these little guys, by the way. That got forgotten a lot on the quiz. It always does. Don't forget them on the test. Okay? So it looks like that. 29. Perfect cubes. Not so perfect cubes. Okay? Is 81 a perfect cube?
No.
Mm-mm. So you have to figure out what perfect cube is 81 divisible by.
27.
And it's 27. So 27 times 3. You have x to the 4th, so we can put x to the 3rd here, which means we have one x left over here. You have y to the 9th. We can put that whole thing in the perfect side. And then you have z squared, which is not perfect, so that's going to go in the not perfect side. And now you can just take the cube root. So cube root of 27 is 3. Cube root of x cubed is x. Cube root of y to the 9th is y to the 3rd. And then you're left with this stuff. Taking it out on your calculator? Be nice. Questions on that? Okay, number 30. Is 72 a perfect square?
No.
No. So you got to figure out what perfect square is 72 divisible by.
8.
8 and 9 would work, but you'd have more breaking down. 36 and 2 is the best option. A to the what? 6, which means there's one a left here, and b to the 10th. Remember, these are square roots, so it has to be divisible by 2 to go on the perfect side, okay? Then we take the perfect squares. So 36 is 6, a to the 6th is a to the 3rd, b to the 10th is b to the 5th, and then we have the square root of 2a. Still with me? I know this is a long haul. Okay, 31. Now we're going to multiply across. So 20 times 5, that's the square root of 100. What's x times x squared? X cubed. Here's where you add them, okay? Y to the 2nd times y to the 4th is y to the 6th. And now you can break it into perfect and not perfect. So 100 is a perfect square, so the whole thing goes here. X squared will be perfect with an x over here, and y to the 6th is perfect. Okay, what does that simplify to? Square root of 100 is 10. Square root of x squared is x. Square root of y to the 6th is y to the 3rd, and then you have the square root of x. Okay, 32. Actually, you know what? Go to 35. I want to make sure we get through that, and then I'll let you guys choose which ones you want to do. Do you remember what to do with this?
The thingy.
Starts with a C. What's it called?
Oh,
The conjugate, right? You're going to multiply by the conjugate. So really what you're doing is multiplying by 5 plus rad 3 over 5 plus rad 3. Okay? Do you remember the shortcut? Do you have to FOIL the bottom?
No.
Can you FOIL the bottom?
Yeah.
Yeah, it's a lot more work, but you can. It's a squared minus b squared is the shortcut, right? So it's 5 squared minus the square root of 3 squared. So really it's 25 minus 3, or 22 is going to be your denominator. Do you remember doing that?
Yes.
Okay, so 22 on bottom. On top, now we're going to FOIL. So this is going to be 2 times 5 is 10, plus 2 rad 3, plus 5 rad 3, plus what? 3. The square root of 3 times the square root of 3 is the square root of 9, which is 3. Okay, so simplify that. 10 plus 3 is 13. 2 rad 3 plus 5 rad 3 is 7 rad 3. Can you simplify anything about 13 plus 7 rad 3 over 22? You can't. So that's going to be your answer. Okay, of the ones that are left, what do you prefer to see, just in case we don't get through them all? 32, 33, 34, 36, 37.
I'll do
33? Okay, so 33, we're going to divide that. So it's going to be the cube root of, what does this become? Eight. 40 divided by 5. X over x,
1.
well, it's x to the first minus x to the first.
Oh,
So 0. X to the 0 is 1, right? So do you have to put that there?
Yeah, I was right.
You are. I just want to make sure everyone sees how you're getting 1 from that.
Okay.
Yeah. So that's going to go away, right? Y to the 5th over y is what? Y to the 4th. Okay, so now break that into perfect cube and not perfect cube. 8 is a perfect cube. Y to the 3rd is a perfect cube. So then there's just y left over here. So this is 2 times y times the cube root of y.
Can you do 32?
Yes. All right, 32. So multiply the numbers out in front. 2 times 5 is 10.
Why did they use an X roll?
It was a dot, but when it turned into a PDF because of the old formatting, it turns it into an X.
Wow.
So on mine, it's a dot. All right, so now multiply this. This is 45 x to the 6th, y to the 5th, okay? Break that into perfect and not perfect, but don't forget about your friend the 10. So square root of 45, what's that going to break down to? 9 and 5. Okay, x to the 6th is a perfect square. Y to the 4th is going to leave you with a y over on the other side. So this becomes 3x to the 3rd, y to the 2nd, but we're still multiplying by that 10 out in front. So it's going to be 30 x cubed y squared times the square root of 5y. What's next?
34.
34? Okay. How do you rationalize this? By the denominator over itself, right? So multiply by the square root of 2x over the square root of 2x, okay? So on top, that's going to be 8 rad 6x. What's on bottom? 2x. When you multiply the square root of 2x times the square root of 2x, that's the square root of 4x squared, which is 2x. Okay, your 8 and 2 reduced to 4 and 1. So you get 4 rad 6x over x. Do you see how I put boxes and circles around everything? Isn't that lovely? You should do that.
Nice.
36 or 37 in our 20
36.
seconds.
Wait, no, 37.
Okay, 37. Square root of 12 is 2 rad 3, right? You can go, but I'm going to keep going. 4 times the square root of 9 times the square root of 3 is going to be 4 times 3. So 12 times the square root of 3 plus 2 times the square root of 3. So 2 minus 12 plus 2 is going to be a negative 12 times the square root of 3. Guys, we only missed one problem? Oh, I did something wrong. It is. What did I do?
Oh, I think you did. I think it's smooth. Yeah, I think it's just 3.
No, it's not. It's, what did I do? 2 minus 12 is a negative 10 plus 2. Sorry, negative 10 rad 3 plus 2 rad 3 is a negative 8 rad 3. My bad. Okay. For anyone that's watching the video, negative 48 minus 10 rad 5 should be your final answer on that one.